Hello everyone, and welcome back to another video from your favorite and go-to YouTube channel about statistics, artificial and facts. Thank you for clicking on this video, and for today's lesson, I would be teaching to you about model regression with interaction. But before we jump into the video, please don't forget to like, comment, subscribe, and ring the bell notification button. Thank you, and now time for the lesson. I will be teaching you about regression model with interaction through SPSS. Now, my dear viewers, you might be wondering, what is SPSS? Well, SPSS is a powerful statistical software platform. It offers a user-friendly interface and a robust set of features that lets your organization quickly extract actionable insights from your data. Advanced statistical procedures help ensure high accuracy and quality in decision making. All facets of the analytics lifecycle are included, from data preparation and management to analysis and reporting. Or, in short, SPSS, or more commonly known as Statistical Package for the Social Sciences, is a software program used by researchers in various disciplines for quantitative analysis of complex data. Now, on to the lessons and the questions that you might be thinking. Why would you use an interaction term in a regression? Well, adding interaction terms to a regression model has real benefits. It greatly expands your understanding of the relationships between the variables in the model, and you can test more specific hypotheses. But interpreting interactions in regression takes understanding of what each coefficient is telling you. What is a model with interactions? An interaction model is a design model that binds an application together in a way that supports the conceptual models of its target users. When can an interaction term in a multiple regression model be used? In regression model, consider including the interaction between two variables when they have large main effects. The effect of one changes for various subgroups of the other. Can you do an interaction in logistics regression? Variable x and z may be binary or continuous. For the special case in which x and z are both binary, the regression model with continuous response is equal to an analysis of variance, or more commonly known as ANOVA. Interactions are similarly specified in logistics regressions if the response is binary. What is the difference between moderation and interaction in regression? Moderation refers to a change in the relationship between an independent variable and a dependent variable. Depending on the level of a third variable, termed the moderator variable, moderating effects are also referred to as interactions and conditioning effects. What is interaction? In statistics, an interaction is a special property of three or more variables where two or more variables interact to affect a third variable in a non-additive manner. What is regression? A regression model is a statistical model that estimates the relationships between one dependent variable and one or more independent variables using a line, or a plane in the case of two or more independent variables. Types of regression: logistic regression, ridge regression, lesser regression, and polynomial regression. are types of regression. What are the benefits of regression? Adding interaction terms to regression model has real benefits. It greatly expands your understanding of the relationships among the variables in the model, and you can test more specific hypotheses. But interpreting interactions in regression takes understanding of what each coefficient is telling you. In regression, the formula is y equals a plus b sub 1 x sub 1 plus b sub 2 x sub 2 plus b sub 3 x sub 1 and x sub 2. Now you might be thinking, what does the letters stand for? So y is what is being predicted or explained. A is for the constant. B1 is for the regression coefficient of x1. B2 is the regression coefficient of x2. B3 is the moderate coefficient variable. And x1 is the first free variable. x2 is the second free variable. And finally, x3 is the moderate variable. This is the note or the key point of the lesson. Component x1 and x2 is an interaction component. We made this variable using the variables of x1 and x2 to make a free variable. We describe the regression equation to three independent variables and test the significance of the third independent variable to individual tests or the independent variables, which are then described earlier in this chapter. The multiplication variable between x1 and x2 is a moderating variable because it describes the moderating effect of the x2 variable on the relationship between x1 and y, while the x1 and x2 variables are the direct effects of the x1 and x2 variables on y. Now you might be thinking, why the multiplication between x and x2 can be considered as moderating variables? Well, it can be explained by making a derivation equation x1 or dy over dx1 from the first equation. The result of dy over dx1 is dy over dx1 equals b1 plus b3 x2 from the second equation. The second equation means that y over dx1 is a function of x2 or variable x2, which moderates the relationships between x1 and y. For example, data. Suppose we want to know the effect of budgetary participation, or x1, on managerial performance, or y, with organizational commitment, x2, as the moderating variable. In this case, we want to know whether the data is a moderating relationship between x1 and x2, or if it is described as follows. The y is 5.00, the x1 is 5.00, and the x2 is 5.00, and the x1, x2 is 25.00. For the second one, it is 4.00 for the y, 4.00 for the x1, 4.00 for the x2, and 16.00 for the x1 and x2. For the third is 3.00 for the y, 3.00 for the x1, 3.00 for the x2, and 12.00 for the x1, x2. For number 4, for the fourth, is 5.00 for the y, 5.00 for x1, 5.00 for x2, and 25.00 for x1 and x2. Fifth one is 3.00 for the y, 3.00 for the x1, 3.00 for the x2, and for the x1, x2 is 9.00. For the sixth, the y is 2.00, the x1 is 2.00, the x2 is 2.00, and the x1, x2 is 4.00. For your seventh, the y is 2.00, the x1 is 2.00, the x2 is 2.00, and the x1, x2 is 4.00. For the eighth is, for the y is 2.00, for the x1 it is 2.00, for the x2 is 2.00, and for the x1, x2 it is 4.00. For the ninth, the y is 3.00, the x1 is 3.00, the x2 is 3.00, and the x1, x2 is 9.00. And now for the 10th, the y is 4.00, the x1 is 4.00, the x2 is 4.00, and for the x1, x2 is 16.00. Step 1. Put the name and label in the variable view. Step 2. Input the data in the data view. Step 3. Click Analyze, Regression, then Linear. Step 4. Input the y in the dependent. Step 5. Input the x1, x2, and x1, x2 in the independent. In step 6, click OK and it'll show the output. Thank you for your attention. God bless you all. But before we go, please don't forget to like, comment, subscribe, and please ring the bell of notification. Thank you. That's all from us. See you next time. God bless.